Hello and welcome back to the development of the Feersum scheme compiler. So in today's stream, I'm going to continue working on implementing some of our core library in Scheme, but I'm going to start off by going over what we did in the last stream. So in the last stream, we introduced a new library, Feersum compiler services, where we've moved a lot of our compiler code into. The idea being that this will be a library that provides access to APIs to do like syntax analysis and code gen and that kind of stuff. We then introduced a new executable, Fearsum Stage 1, which isn't something we're going to ship. It's just a thin argument parsing function that then calls into the main compiler in the Fearsum compiler services library. The idea behind this is we can then build this ahead of time, then use this to compile the Fearsum core library, and then which is written in Scheme. So this Fearsum core library uses this use stage 1 compiler props file. So we have some MS build tasks that then build the stage 1, and then when that's built, use that as the compiler to build this assembly. And then the final bit is the main compiler now basically just has the REPL in it, and it can now directly reference Fearsum core, which means that when we use the REPL, we can now reference stuff that is in the core library. So if I just run the REPL, we should see that I'm able to access stuff from things like CXR. And there's no longer a circular dependency between the compiler and the standard library. So if I do import scheme CXR, then I can do like CAAR of something like this. I'm closing that, which returns the list 1. And if I do like CAD or CAAD, we'll get an empty list. I have no reference somewhere or other. Doesn't matter. Point still stands. And that's all well and good, but there's a few rough edges with this. The first one is that we don't actually include, so in the eval module, we generate an assembly into a memory stream, and that's what's powering the REPL. And in this, we have this options, which is this default script options at the moment. Default script options starts off with these like compilation, just the base compilation options, but the actual REPL itself doesn't just call eval, it calls eval with and passes in an options that contains a reference to the Fearsum core. So this is actually like type of list program assembly location is actually, if you hover over it, this is the list program that's coming from the Fearsum core. So this is just a way of getting the location of the Fearsum assembly. I wonder if there's a better type we could use there. We'd have like Fearsum. Script body. No, we'll leave it like that. But the core point here is that the default script options don't contain a reference to Feersum core, and they can't do because these come from the default options come from too far down in the tree. We haven't built the core by then. And the same is true when we do a compile. So in the program, the main program, we create a compilation options. And in this case, we don't actually add any extra references. We just add the references from the arguments. Which means that if I try and write a program, I need to explicitly pass in a reference to the Feersum core. So if I look at run spec here, to be able to do something like where's this not? Oh, that's because that's the wrong terminal. I wanted this one. If I do run spec CXR to run the CXR tests, call import scheme CXR. And so for those to work, we need to have a reference to the scheme core active. And at the moment, this should, when it all compiles the first compiler and then compiles everything, compiles our code and then runs it. I don't know why this is taking so long, but it should all work because we have this -- reference, which points at Feersum core DLL. What is it up to? Oh no, it's worked. I think. Has it? Spec. Bin. I think. Spec bin doesn't have a slash on the end, so we've created a file called spec bin instead. Where do we? I don't know. Spec bin. How do you run spec CXR? This is going to be one of those Yak Shavy episodes by the sounds of things. Ah, it worked. It was the folder thing. And then we've ended up with all of that working. But if I take away this reference, this should fail because it won't have a reference to the library. We should end up with an error saying, oh, you can't import scheme CXR because I don't know what the library is. Ideally, people wouldn't have to remember to do this. So I think the first thing we want to do is just update this program so that by default, so our get results is going to return us the list of all of the reference strings, but we really want it to be something like that plus list and then it'd be nice if we could extract this into like let's just make it a public thing. So just let core references, and then for the time being that'll do. Like that. So now that should work again. because it should be implicitly adding all of those by default. So that's one thing. I'm going to stage that. So I've got something banked. Use or just try and decide whether or not they should be considered core reference, because I think we have this MS core path, but I think we want to move away from using that and have just MS core paths for the MS core lib itself. We have a comment. Vol Warframe says, "Hi, how do you like my new program, Angus?" I mean, we'll have to find out. I think this is a meme. Bunnycraft YT says hello. Hello. I'm guessing is YT YouTube? I don't know. It is to me. Fixed the const squared. I don't understand what you mean by that. So that, I guess, is linked to Fearsum Co-op, but that then moves us on to the next bit, which would be, it would be nice if we could write more of the scheme library now. So I'm just going to get the R7RS spec up. And we'll have a look at what we can do in terms of pairs and lists, because I think that's where I was thinking of going next. Yeah, so we currently implement a little bit of this Lisp library in. We have the lists, is it .cs, which has things like length and car encoder and things like that. But some of this could be moved into pure scheme, especially things like, well, length is just a purely recursive function. I mean, well, we've implemented with the while loop, but we could get equivalent code, you'd hope, from our compiler. So yeah, pairs and list standard procedures. So we already have pair and cons and car and coulda. Do we have set coulda and set car? I think so. No. We'll need those. So we'll just implement those here. I'm just going to copy and paste and then edit because that's quicker and easier. So set car, set coulda. We need these to be in C# because they're going to mutate the underlying types, and we need them to exist so that we can write the more complex things in Lisp itself. So we're going to unpack that, and we want there to be a cons pair and an object, and the same here, which is going to be list and new car. And this is going to be list and new coulda. And then we're going to do well, yeah, I think we want to do list.car equals new car and then return car. I don't think it does it really matter what set car and set coulda return. Just says it'll throw an error if there is none, but you're allowed to throw an error if it's a constant list. We don't really have constant lists, so that's fine for the time being. The idea there is that you can have like some, if you're going to do quoted forms, you can have them just as things that are baked into the binary itself, so you wouldn't be able to mutate them. But we don't really do the world's greatest job of quotations and using consts for those yet. So we've got the same thing for set coulda. It doesn't do anything interesting. It just signs it. We can make it we can make it either return the object or we can make it return undefined. What is this? I don't know why I'm missing a whole load of project not loaded. Do we need to restart? Yeah, I think we do. Restart OmniShop. It's not in a happy place. Right, reset car. Reset coulda. Wow. Going from worse to worse. Implicitly typed variables cannot have multiple declarations. Well, like, really what we wanted here was to unpack those like that using the deconstructor, which I'm sure I'm pretty certain unpack args here is returning. Keep on trying to highlight over it to try and get it to show me stuff, but for some reason, project not restored. Why are you unhappy? Do I just need to kill and reopen code? Maybe. Wow, that was loud. Let's turn that off. OmniShop is running. Okay, and now if I do lists, some projects have trouble loading. Git version is not happy. Well, somewhere in here we have, there we go, Git version ms build. So let's just comment that out for the time being. Then I guess restart OmniShop. This could be a Fedora 35 thing. I updated. And it only took me several hours to get it back working the same way it used to before. The pains of actually using Linux and having an NVIDIA card. Git version.msbuild.targets. Why would you still... Do I need to close and reopen you again? I think I might do. I think that the OmniShop stuff might have remembered that Git version msbuild was still loaded. What? Do I have Git version anywhere else? I have this package reference that I've just commented out. And then the generate Git version information, which shouldn't do anything if the package isn't there. Let's see. We've got a whole load of build server stuff running. No. Are they still going? Why? .NET build server shut down or something? Oh, it's just shut down. Okay. How about now? That's still there. Now, if I code, is it going to work? Pretty certain there was something memory resident that was remembering the fact that we used to have a reference to Git version in our MS Build stuff. Well, the Omnisharp server stuff has not turned red yet, which is good. And we've got some, like, actually useful squiggles. And it's telling me that I've spelled undefined wrong. Nope. That one? No. Why is control dot just making an E? What does that even do? Is this some key binding? Command palette? No. But we can go find the preferences. Extensions. C#. That use global mono might be the problem. I wonder if OmniSharp's trying to use its own local copy of mono and doesn't work with this version of Linux, because I hear that there's changes in libc that was breaking some people's things. Yeah, nothing useful in that. Nothing obvious in terms of key bindings. It's kind of... What does this say? Introduce parameter. No. Cannot be assigned to. Interesting. We kind of... We want it to be assigned to, though. I think we only ever knew these up using the constructor from generated code, so I think we can just make these auto properties. Like that. How about now? That sounds really awkward. I think there's a raise condition in the way that we build this compiler. So wow. It's built fine 5 minutes ago. Generate depths file. Yeah, I'm pretty certain that we raced to compile the compiler twice for the two different target frameworks, and that's the problem. So we get some, see, it's built twice, once there for .NET 5 and then once there again for .NET 5, and sometimes they trample on each other. Hmm. Now we've got OmniShort loaded. Can I just uncomment this so that MS Build starts producing version numbers for us again? This is looking more positive. I shouldn't have said that. Gent runtime, yeah. This needs fixing, doesn't it? That's the stage 1 that's failed that time. The thing that's the same is that both the stage 1 compiler and the main compiler are built twice, because the things that we have some test projects that depend on the main compiler that use different architectures. So like this one uses Net 4.7, this one uses Net 5. And we have the core itself that's built for both .NET 5 and .NET Standard 2. And so that means that the core gets built twice, effectively, which means that in the core, we have the reference to use stage 1 compiler. Use stage 1 compiler has this target which runs MS Build. And so it's running MS Build twice with the same compiler configuration and the same hard-coded .NET framework. And that's, I think, what's resulting in these collisions. Now, in theory, all of these MS builds are being run in the same process, so we might be able to get away with doing a produces. Is it outputs maybe? Something like that. Yeah, I think we put outputs, and then if we just include that like that, will this improve the situation? I don't know whether or not this building cleanly will prove something. I guess the only way you can prove it not having the race condition would be if it never did it again, which is impossible to prove. Let's try putting that in the main compiler as well. So use local compiler. Feersum compiler path. That's looking. It didn't fail. It didn't fail then, but then didn't really have a huge amount to do. It might have done it. I guess we'd have to clean it and rebuild it to now. Oh, yep. C# extension's unhappy because of the mono stuff, I think. I might try changing that. User settings. Nope, that's failed again. I set it to use local mono never for a reason. But I can't remember what the reason was. I think we'll live with this slightly buggy compilation stuff for the time being. It needs a in-depth dig into it. We used to have project reference rather than an MS build called directly in a target. And that did seem to be more reliable. But the problem was now we're dual targeting some of the... We'd end up trying to build the stage 1 compiler as like a .NET standard 2 executable, which just isn't a thing. You can't build an executable against that target framework. So I'm not too happy about this whole thing, but here we go. Set cars, it could set can't hurt though. So now we've got set car and set CUDA. We can start looking at implementing some more of these. So we've done the CXR library. We've got null and list predicates already. Make list. Do we have make list? Yes, we have make list. We have the list function. Do we have a length list? Yes, we do. So append and reverse. These would be good ones to implement. And let's go over to the core library and start implementing it. Lists.cm. We'll have to add that into here so that it gets compiled. And then in here, we can do define. But this is where we end up at a problem. So just going to call it hacks lists for the time being. Export, append. I'll begin. Define, append, list. People call this list of lists. I'm just going to read it. So the last argument is, okay, so append is variadic, so you can take any number of things. So we want this to be lists like that. And what does it say? Let's go find some spec. We can start writing some tests for this at the same time. We have list.scm already. So how about display? So you got append x and y should become xy. That seems simple. Yeah, I mean, this is going to return null, I think, because I've written the function. But we haven't imported hacks lists. So it's going to fail to compile that. Takes a long time because this is compiling the compiler, compiling the standard library with that, then compiling another version of the compiler that uses that standard library, and then running the compiler against our spec test to compile that. Plus it's doing that for 2 target frameworks, I think, because, or at least for the first compiler, because we need to build a .NET Standard 2 and a .NET 5 copy of the core library so that we can target things like Mono and other old frameworks. Reference to undefined symbol append. Well, that's what we want. Is it? What we want is the ability for this is just listed as procedure, and so some parts of the library here, for example, say CXR library procedure. So if it says CXR library procedure, it means that it should be in a library called scheme CXR. If it doesn't say which library it should be in, it should be in a library called scheme base. We have a collection of hacks in Sharifa. We have like things like, if I go to the lists CS, this is defined in the library scheme base. But if I have a look for this attribute, Lisp library scheme base, we actually use it several times. So the way that our generated code works is that there will be one class which has the attribute scheme base. But the way that this this kind of like C# style library declaration works is that we've got multiple copies of scheme base. And then in, I think it's in built-ins, we do some stuff to deal with this. So I think it's in import core. It's not. Reload core types. Something like this. because we have the core macros that are also supposed to be in scheme base. And what we do is we take all of the libraries from the core, group them by the library name, and then basically remap them to produce one unique library signature for each one. Which works. But it'd be nice if we didn't have to do that. Plus, we only do it for the core signatures. So this Lisp core location, which is the Shriver assembly, we don't do it for anything that you reference. So if I defined lists up here, so the other lists, the one in the core, as scheme base, you'd hope that I was able to import that as scheme base. But I won't be able to. So I think the solution to this is that none of the stuff in the core library should actually be defined in scheme base. So nothing stuff in Shriver should be defined in scheme base. It should be all defined in like Feersum Shriver arithmetics or something. Feersum scheme, booleans and same kind of stuff. And then the stuff that's in the core library can just generate generate a library declaration that re-exports it. So I could do like I could have like one declaration that's called base. Let's actually start to sketch this out. Base CM. I always do CS first. In fact, let's get rid of that because I actually have a template for this, I think. So if I go to source core, no, I think I can do .NET new scm lib name base, and then we know with base.sld, then I'm gonna put base in here. Base one's going to last because it's going to import stuff from the other ones. And then in base, we would do scheme base. And instead of importing scheme base, we'd import things like Feersum, Feersum core lists. And then we define this as Feersum core lists, export append. In base, we wouldn't have a begin block. We just have an import declaration and an export. And the export would be like append, blah, blah, blah. And all the other things that we want to export. The problem with that is if I was to compile this now and then have a look at what we've got in the assembly, those re-exports work when you're doing it in the same assembly, in the same compilation, because we have the library definition in memory and we know what it's exported. But when we're rereading these library definitions and reconstituting them from the metadata that we get in assemblies, we don't have that information. And so if I do monodis on the bin debug net, Let's go net standard. Doesn't really matter. Feersum core. We have scheme base. It's got a constructor. It's got a library body, which is basically all it does is initialize the library it depends on, which is in this case lists, but there's no interesting things in there. And then there's this thunk, which I don't think we really ever need. That's probably something we should just stop emitting. But the key thing is that there's nothing in here other than a constructor and this attribute. There's no metadata to tell you we've re-exported something. So I think that's where we'll start digging today. So let's go to... Right. I guess the first thing is we've got that Lisp export and the Lisp built-in. They are very, very the same. And so the first thing I'm going to do is get rid of Lisp built-in and replace it with Lisp export so that we can simplify some of the code. Lisp. So we want to find all of the places where someone's used Lisp export. I think. This does not make sense. Surely some... I've already moved everything over to Lisp built-in. Was it Lisp built-in? Oh, no. Did I just delete the wrong one? No, I didn't. Lisp export exists. It's Lisp built-in I should have been searching for. So every time we say Lisp built-in like that, we should just be saying Lisp export. And then every time we say Lisp built-in attribute, that's where we need to change things. Right. So built-ins, we need to do anything that... Is that going to work? Choose matching should probably be like find exported, and we'll just inline this name. Find exported on matching of things, and then this can just be find exported fields, find exported on the methods. That's simpler, I think. I think we can simplify this even more. I think on matching can just become either field or method. And we can just pass dot name in it. Like, and this probably just wants to go into one line now. Although Fable is so Phantomus is the one that has opinions on that. So now I did automatic code formatting, so I can do dot. This construct causes code to be less generic than indicated by the type annotations. Don't understand what's going on there. Let's just undo some of this refactoring. Were you happy with this? Should be a sequence of A when A is something that inherits from custom attribute. Cool. But then if I do, so that means that the sequence of things, when I do thing here must be something that has custom attributes. And then when we do yeah, we'll leave it like that. It feels like it shouldn't, unless it was when I removed field down here, we were inferring a different type for this. That's when I removed the function. Anyway, now we are getting the exports and the built-ins. What we want to do is add a new attribute type for Lisp export, which I guess should live in the same place. So this one wants to be Lisp re-export attribute. I don't really know. I guess it would be re-export like that because you'd have a dash in it if you were going to write it normally. Then this re-export attribute is going to be class. And mark a re-export list. Signed in triplicate here. So string. And then here we want like external name. Because the key thing here is that when you re-export something, you can change the name that you export it as. Do we need... No. String... library name, string item. So in this case, we'll say like exported name. Wow, that did not go well. Exported name is the external name. We'll also have, actually, there should be a refactoring for this, right? Oh, I forgot. Control dot returns ease for some reason. Create a property. Oh, there's one there for creating assigned properties for remaining parameters. Too late now. Summary gets the name of the exported library name. This is not going to be the world's greatest representation. And at some point, it'd be nice to stop relying on all of these attributes to bake all the metadata in. Instead, we could create a section in the assembly and serialize it in our own format, so we could come up with a slightly more optimal way of representing all this stuff, because this is going to bloat the size of the assembly, especially if we've got to do an assembly name for every single export. I don't really know what else we can do though, because really what we want is a reference to a field. I don't know how you would do that. Like, let's have a go at sharp labbing it. So say we have public class foo attribute, which is an attribute. It's got a constructor. Which takes object. and does nothing of use with it. And we try and put foo here. We need to give it something. So one would get boxed. What does that look like in IL? This is like a boxed one. What about if we try to reference a field? Public int foo. Foo. I mean, you're not supposed to have public fields, so I don't know what the casing convention is. I think the casing convention is don't. How would we? Foo here. Must be a constant expression, a type of expression, or an array creation expression of an attribute parameter type. So you can only basically have constants, type references, or arrays of those. So I do type of C. What do I take here? Do I take a type? So I can do like type of C, name of foo. And then we can take a type and a string name. Okay. That's probably more useful when we're going to load the metadata back. We don't have to have so many string arrays. So let's make it a type. Library type. String item. And then, yeah. That can be library type. Which must be type. We can just say the library the item is exported from, and then this can be. Oops. No, just did the same thing. Get the name of the item to re-export. Library item. So what we'd have to do is in built-ins, we're getting all of the exported fields, all of the exported methods. We'd also want to go through all of the attributes on the type itself and get those. So we'll let re-exports I dot custom attributes seek dot choose Yeah, I think we're going to do seek.choose again. This is the attribute. Well, attribute name. Oh, it's attribute type. It is. It's attribute type dot name is Lisp re-export attribute. So it's try pick returns a single item, doesn't it? So this would be if the attribute type was that, then we return something. Otherwise, we return none. And then need to make sure those brackets line up. Why am I not getting any help from Ionite here? It's not installed. Interesting. What went wrong? Don't seem to be able to restart Ionite. I'm gonna have to restart the whole editor. Right. At least we've got the badge now. Where's it up to? There we go. That's what we want. At type annotations. So we want this to be a sequence of string storage ref, don't we? So if the attribute type unpack string arg, I think unpack string arg should take an index. That. And then we can do, this is going to be a pair where on the left hand side we have unpack string arg attribute 0 because that's the exported name. And then on the right hand side, what are you upset about? Oh yeah, fair enough. You expect an expression. I expect an expression too. And this is going to be a global. I guess. Now, don't know how mono would reference we need to do something with the second string argument. We don't know whether or not that's a method or yeah, we don't know if that is a re-exported method or a re-exported field. We'd have to find it. And we don't know what its exported name is. We only know, well, I mean, we haven't decided what putting in the attribute yet, so we can just turn that into a method for the time being. So that full name needs fixing. But we need to find some of these. We need to have some of these attributes first. The question is, I think this just wants to be seek, or is it list.concat maybe? And then we can just put exports, built-ins, re-exports. And then we don't need to list of seek that. This needs to be seek.concat, and then list of seek. So at least the types check out. We need to fix up that full name, and we need to fix up the method. To decide if the re-exported it's starting to feel like we could do with some of the pre-computed cached values from the earlier libraries that we've scanned, but we don't necessarily guarantee that we don't guarantee the order in which we're going to run through these references. I think we need to emit one of these attributes to work out what it's going to end up looking like when mono Cecil gets its hands on it. And we can stick it in the debugger and find out. So let's just go to, rather than trying to do it ourselves, let's go to list and just do a re-export. Or let's create a simple library. Test hacks. And then that's all we need for that. We can do list re-export. We're going to say foo, and we're going to re-export from type of lists. And we're going to re-export null because yeah, I'm trying to think how the library signatures are going to look like when they get serialized. That's going to be down in emit, because we might want to do null like this to match it with a Lisp export, but there's an extra level in direction here. If we already know the type and the underlying method, we could just do type of, effectively the equivalent of doing type of lists, name of null check here. And then when someone finds this signature, they'll say, if you try and re-export foo, we'd still be able to say the actual real thing that you're re-exporting would be type of list, name of null check. I think that would work, which is in compile. So the compile gets like a dictionary of all of the exported types somewhere. So the external types, type export starts off as map.nt, and then for each library, what do we do? So if it is exported, we call mark with exported name. When we stub out the field, what is the type of these exports? It's just a map of like type name ID to string. So it starts off with exports. I think exports are, so exports here is the exports from the whole library. Okay. But we know... Do we know what our mangled name is at this point? So if we've got the exports, they're going to be... If they are globals... Because we could work it out here. And we've got the library type. Do we know what our mangled name is? Because exports doesn't... For a given context, we don't need to know the mangled name, I don't think. Back Tomcats is morning, mate. Morning. It is still morning. I can't believe I had to check that. It's only 10:30. Yeah, if we only ever look it up here by... So it tries to find the type name in the library. And if it finds the type name in the library, it finds the field with that ID. And if it doesn't, it makes a new field. But that... Find the external type. Find the field on the external type. If we can't find, so type. So context libraries is the libraries for the current emit context. What you're compiling? We're compiling scheme using a compiler in F#. I'm currently battling with re-exports. So I'm trying to move it so that some part of the standard library for this compiler can be written in scheme. And the problem there is that we want to be able to define libraries like the scheme base, which do something like import all of our internal libraries and then export the symbols so that when people import scheme base, they're actually getting a bunch of different things from a bunch of different other libraries. And then that allows us to split the implementation of some scheme libraries like the base library between stuff that's compiled from C# and stuff that's compiled from Lisp. But although the compiler at the moment supports export statements for libraries that are defined within the same assembly, we don't emit that metadata anywhere. So we're just trying to define how we're going to store that. So I've added a new attribute for marking up types. Lisp, not list, re-export, which is going to say re-export as some name from this type, this item. I'm just trying to work out how we would actually serialize those when we emit a library that does do this kind of re-export, so that we can then work out how to re-import them on the other side. So the thing is, we're always gonna add the type, the field, regardless of what the actual type name was. We're always gonna add it to our new type. So that shouldn't happen. So we don't need. Yeah, I don't think context export should ever contain anything where the type name isn't our type. So I'm just going to get rid of that from the exports and see what breaks. Am I? Like, it was probably there for a reason. I mean, I understand that we put the mangled name in here, but I think we need to split those. So I think we need to split it in what we do here is we take the exports, we do a fold to collect all of the exported items from the current type and all of the exported items that are re-exports from another type. And for all the re-exports from another type, that's where we'd add the attributes. And for all the ones that are from the current type, we'd put them into this dictionary. And then when we come to look things up here, we only need to worry about the ID. Tie in this case though is the current. So context libraries is the library types. So you know type name and tie are the same here. So we are always adding it to the right type, but why are we? I don't think we should. I don't think we should ever get to the point where we haven't properly defined, and the type here would not equal the context type. I'm gonna just try that by doing if context program type, so the current thing we're compiling does not equal type, the things that we're going to add the field to. We'll throw an error. Or field. And we'll put the field on the end. And run the tests. needs to compile. Try and work out whether or not at some point we'd be like backfilling fields that were never defined when the original library was compiled, but someone else uses. Doesn't sound like something that should happen though. There's a few errors there though. Is that just because I've edited the list, the library for lists? I think so, yeah. It's just lists not passing the same. So, if we're always compiling for the same thing, we can pretty safely that's a really terrible error message if you saw that as an internal compiler error, but it'll do for the time being. So we know that the type name is the current type. So if we do try find with ID, go and change exports to only contain the string for the ID. So this is going to be the raw name, this is going to be the exported name. Then when we've fixed up the lookup, and then this here wants to be, if we find something mangled, where mangled is our current type name, then we return some. Otherwise, return none. And this is going to be some ID like this. So it's just going to be the power of the ID name. Then that should all compile again. Let's rerun the tests just to be sure. And I might actually back out the changes to the list spec just so that it doesn't fail. If we can guarantee that, we'll change this from being a choose to being a fold. And we can build up two lists instead. So instead of seek choose, we can do seek dot fold. Which takes a folder which is going to be state name storage, and it's going to return state each time. So if it is a global, if it's not a global, then we just return state unmodified. Our state is going to be a pair of lists. On the left-hand list, what? Oh yeah, it doesn't want to take a pair. It wants to take two arguments. The first of which is the state. The second of which is a pair. In this case, we want to do well, let's say state is going to be so if we find a global, we'll do let exports re-exports, and then we can just paste them back together. So it'd be we don't need to map of seek that anymore. Then we can do let exports. Oh, we can do map of seek down here, can't we? Terrible casing. That needs to be in an M, capital M. We don't do anything with the re-exports yet, but we should loop through those re-exports. If the mangle name equals our mangle name, it's going to be an export. So we put ID no, is it name ID? Paste that onto the front of exports. Otherwise, we paste can I get the whole of this part of the pattern again? I think there's a way of doing it. As list array tuple wildcard. As just paste G on the front of re-exports, I think. Because really, that's what we want. But so now, what is re-exports? It's a list of storage refs. Is it though? Probably, because we've probably need to do that. No, because then the pattern doesn't match. If I do this, we can deconstruct this inside. We could then do let mangled. So yeah, mangled, and then item equals G. And we've got mangled. That. We can paste those together. That. And then ID is we only support exporting fields at the moment. So we can do field ID becomes that. Anything else is an internal compiler error. That wants to be ICE format. Now what is re-exports? It's a list of strings to global type, which I think is what we wanted. Because we can then do re-exports to list at iter extern yeah, these are pairs. Extern name item missing a function body. Yeah, that's fair. Then here when we're re-exporting, we just want to create these attributes, so we're going to need to find. We'll just call mark as re-export. context core lib tie extern name item. Then we need to implement markers re-export. Take some core types. We take a library. And we take an extern name. And we take an item. And does unimpl take them? Yeah, it takes a message. Next. Add an attribute marking the given item as re-exported. The name, new name from type. This should still kind of work because we don't do any re-exports yet. Or are we going to get a bunch of exceptions? Let's go to core, load core and built-ins because we're going to need to put something in core types so that we have a reference to the attribute. So Lisp export, Lisp library, Lisp re-export. It's going to be a method reference. And then down here, Lisp re-export can be get single cthor, and then we'll just copy and paste, just like we did for the library name, and type those extras in. Hopefully that should find that. Then we've got, so we've got the core types, we've got the type definition. We need to add an attribute. So we need to do let attr equals core.lisp re-export as a custom attribute. And then we want to do we want to add these things to the custom attribute arguments. So we're going to first add a custom attribute argument for type dot modules dot type system dot string ext for the external name, something for the second argument. I've copied and pasted bad code here. And then the last one is going to be dependent on what the item is. I reckon global ID can be add the ID. And then anything else, which I think is going to be method ID, we can just say unimplemented re-export of methods. Gonna need it though. Is it storage ref? Why is it a storage ref? Why do you think? So here it's a global type. So why do you think it wants to be a storage ref? Does this just want to be global type? Field. Fields and methods. Fair enough. So the question is, how do we represent types? Which I guess could be called up type. And then the other one is going to be how do we pass this type in? I mean, we should have the type. It's going to be the library type. Core type doesn't exist yet, so we can find it. So we want a type reference. Type tie. Then down here, we get the environment type. Ported type of system.type. I think that's it, right? And the compiler should have access to type. We just need to fix up the call site for markers re-export. This wants to have a third thing in it, doesn't it? This wants to have name, mangled name, item. And this wants to be name, extern name, or extern name, lib name, lib type name, item, and lib type is going to be context dot. Do we have some way of searching through all of the libraries and types already? Libraries. We have it in get fields. We have get extern type. So I think we just need to do list try find on the libraries and then fall back to get extern type. Default value or default width get extern type libtype name. Then that can be external library type. Get extern type needs to take the context. Fair enough. We just want to do map.try guess, I guess. Try find. And the key is going to be lib type name. So if you can find it in our local collection of libraries, we return that. Otherwise, we search for it as an extern type. Now, does this compile? Follow-up question, does it work? I'll take work as being run without throwing any exceptions. Interesting. So now if we have a look at source fearsum.core bin debug net5 fearsum.core monodis. No, please don't tell me all of those. Monodis. And scheme base is here. And we haven't done any re-exports. Okay, fair enough. But why? That compiled though. Because if we did something that didn't exist in core lists, we'd expect this to throw an exception or fail the compilation or something. Yeah. No. The Feersum core still compiled. Why? I don't know, but I'm out of tea, so I'm going to take a break and I'll be back in a few minutes. I'm back and I've got coffee. So I think the plan should be set up a debugger and then see where we can get to. So we have launch config. Here's some REPL, blah, blah, blah. Let's do one for stage 1 compile or something. So it's going to be a core CLR attached to, it needs to be Feersum stage 1 bin debug note 5 Feersum dot stage 1. Pre-launch task can be build stage 1. And then we need a task in the tasks JSON. So this just needs to be build. This is the test. I copied the wrong one. Build stage 1. .NET shell build like that. Kind of build. Its default is not true, so you need to do it like this. That is the most awkward thing. And we want to pass in a dash dash project and the path to stage 1. So if I did all of that right, we should now be able to do stage 1 compile. No switch dash dash project. I didn't do it all right. Tasks JSON. Do we just do that like that? Re-exports. Find out how it goes. No. Let's get rid of all of the breakpoints. Start from the beginning. Ah, yes. Missing argument output, eh? What are the arguments we've given it? None. Why is output? Apparently it's just mandatory for this stage 1 compiler. Fair enough, because we're doing arg get result, I assume. Kind of do with the whole arguments list for this, but we can come up with a cut down version. So the arguments are going to be well, we're going to do it in source Feersum core for a start. We're going to pass in cxr.scm. Let's just do lists.scm and base.scm, which is actually base.sld for reasons. And we can do dash output. Workspace. It could just be bin test. That should work. Should be enough. Because all we need is sources and output. Exports is going to be an empty list, but why? So this is the okay. So this is append is exported from list as append. Right, good. Then the next library compiling is scheme base, right? Which is the mangled name scheme base. Has no exports. But why? Have we filtered them ahead of time? Somewhere further up the stack? When we made that library, we must have. Let's run this again and find out what the binder produced. I mean, it looks like it should export something. What are the declarations? So that says export plain append. Then the second library, which is, it says plain from, oh, it's got import from Feersum core, export plain append, plain fob. Okay. See this lookup export. Could not find exported item. So it must be in, I'll put a breakpoint and lookup export. And we'll just step over it and see how many. So we call it once with append, exported as append. We're gonna look that up in this. So what do we have? Right. Why are you not going to find that as append? It does. Then we fail to find fob. It's the exports. Exports look correct there. We've omitted the diagnostic for the bad one. I'm returning the library. Which looks like this. Where the item 3 is the append, right? So what about when we come to omit? Fearsum core lists. And now we're compiling scheme base and exports aren't empty. So it must be something to do with when we fold. So the storage here is Feersum core lists append. And we're going to match that with global of some item. We take the state, unpack it. If the mangled name, Feersum core lists, equals scheme base, it doesn't. We're going to say exports re-exports. So surely re-exports should, yeah. Okay. And then we're going to list it of this. External library type is based on Feersum core lists. And then we're going to mark as re-export. This is a really silly error. We just needed to add it to the type. We built the attribute up, but we never actually put it anywhere. Question is, now will this fail to compile? Because I feel like we are only handling re-exporting of fields, and definitely someone somewhere will be re-exporting methods somewhere, surely. No? Let's have a look at what the disassembly looks like now then. No one mentions re-export. Try rebuilding. Yeah. .NET build source Feersum core. She's built Shreefer. It's built the compiler services. It's going to build stage 1. Then it's going to build our library. Now, what does MonoGIS say? Okay, so we just hadn't updated the library for some reason. Potentially a bug in our SDK. Oh, I know what it'll be. It will be that because what we changed was the compiler, not any of the source code for the library. MS Build didn't know that it needed to recompile the library because it thought that the library is up to date with respect to the source, and it wasn't wrong. I think that might work because it looks like we're re-exporting the external name append, Feersum core lists, the type, append, the thing. How can we prove this out? I think what we'd have to do is just find everywhere where we currently call scheme base. And replace it with a unique name, and then we can re-import each one of those. So we can call this Feersum Shreefer arithmetics and stuff like that. So we take this, and then like this one would be booleans, and this one would be byte vectors. Characters. Equivalence. Lists. Strings. Symbols. Wow. Trying to type around a coffee mug is not helping here. Vectors. Then, with all of those renamed, we can go to the way that we load built-ins. And in here, we also fabricate a scheme base because we have the built-in macros. But we can call this instead. We can call it Feersum built-in macro. Ooh. We don't have any way of serializing macros. Yeah, we'll carry on with this. Here's some built-in macros. And then the place where we do the group by library blah. I mean, that might just be that now. And that's already a list. And then, if I try and run the test now, everything will fail. Because all of that code in the depends on stuff being in scheme base, which it isn't anymore. So we need to make this base import all of those different Feersum car, coulda, all the rest of that stuff. Feersum what did I call them all? Why can't I find them? Yeah, we need to go through and re-export these from base. I'm just going to close all the windows and then do it one by one. So we'd need to do import and then that. We could just do all of the 3-for-1s in one import statement and then all the other core parts in another one. So we've then got booleans byte vectors. Characters. Let's just do them all like this. Equivalence lists, strings, symbols, vectors. And then we'd export. Oh, this is going to take forever. Let's just start exporting the important ones. I think this might be an off-stream thing for me to go through and do all the legwork for this. CXR. Define symbol car. Yes, so in here we need to, actually in the library, we would import car da 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 da, just to neaten things up a bit. You had them there. So instead of importing scheme base, we'd import Feersum for lists instead. Hopefully at least the core library will compile now. Nope. I think we missed something. Re-export of methods. I think we need a third argument here. I think we have Boolean, a third argument, a fourth argument. I think we have a Boolean that just says, is this a method or is it a func? And this would be Boolean true. False. Re-export. We can make a property. automatically. No, we can't, because for some reason that generates an E. We need to find out what the hell's going on there. So that should work. At least compile the core. Cookie Jack says, "Hey, we'll speak. Are you photos of nature?" I don't know which photos you're talking of there. Probably something on my old Flickr. I haven't taken any photos in quite some time. Okay, so it compiles now. Do the tests run though? So this means we're able to generate the re-exports. What? Path spec. Oh, are they not? What? Let's just do it from the command line. Yeah, so all of the tests are broken, but to fix those, I need to go through and just manually move all of those declarations in. And I think it's 12 o'clock. It's time to wrap things up. Git add dot. Generate re-export attributes. Still need to move all of the scheme. No. Declarations to be re-exported from base. So the idea here is that we've got to the point where base will actually be the definition for the scheme based library, and we can define stuff in other libraries and just re-export it. So if I go back, find my monodis, we should now see far more re-exports. So we're initializing all these CXRs, and then I forget how verbose RIL can be at times. And then, yeah, so here we're saying like make list is from Sarifa lists, make list, set cutter is Sarifa list, set cutter. And then at the other end, we're able to import that metadata and correctly generate references to those. So thanks for watching, and I'll see you next time.